Hi, in this video, we want to take a look at block clustering of binary data. Okay, so here's a situation that we have. Let's say that I have some test data, and each row corresponds to a student, and each column corresponds to a question. And in this video, this is fake data. This is from, we're going to be using a data set from an R package, the block cluster package, in fact. So I'm not violating FERPA by using this data at all. But let's pretend we're in the situation that I'm a teacher and I've got some test data and I've got zeros and ones, 0 for incorrect, 1 for correct. Each student is corresponds to a row, each question corresponds to a column. And what I want to do, I want to go back over the material that was missed. Now, I want to tailor it to my students, but I can't tailor it individually because that's just too much. That's not feasible. So let's say what I want to do, I want to go over the material and I'm going to break up the class into 2 groups. And then I want to look at the individual groups to see what would be the best material to go over. Well, if I'm going to put the students into 2 groups, that's very natural to do clustering, right? Okay, well, that makes sense. That's clustering on rows, like typical clustering. And if I wanted to do, I wanted to see which questions had similar performance, that would be clustering on the columns, would be like variable clustering. Okay. Now, it would be nice just to do each of those by themselves and run with it. But there's something missing in that. Yes, I would get my groups of students. That would make sense. But when it comes to the curriculum, I wouldn't really know what is tailored to students that well. What I would need to do, I would need to go through and kind of look at each individual group, their data after I've done the clustering. Well, what if I just want this to be done in one fell swoop, real quick and easy for me? Well, here comes block clustering to the rescue. All right, so what's going to happen is if we simultaneously consider questions and students when we are clustering, then we're going to get students who need similar curriculum help. And we'll be able to identify, hey, for this group of students, this is material to go over. For this group of students, this is material to go over, and don't bother with these other concepts. Okay, so, and in this scenario, for this example, we're going to say that we want 2 groups of students, and I'm going to break up the curriculum into 3 different topics. And I'm only going to just pick 1 for each one. I'm just going to say, hey, I believe that there's 3 groups of concepts for the questions, and I'm going to group it up that way. That way, it's a small enough manageable chunks for me to have instruction with the class. Okay, so first thing I'm going to do, I'm going to get the functions and the data that I need. So I'm going to get the block cluster package. Now, we'll notice that the RT core package comes along, and the C++ with R package comes up, and there's a little bit of package confusion going on, but it won't be an issue for this example. But if I wanted to use LD flags from RCPP, I would have to watch out for that. Okay, so here we're going to use the data that's from the block cluster package called binary data. So I'm just pulling up the data, loading it nicely. And I'm going to call it binary instead of binary data, just so that's a little bit shorter, a little bit easier to look at. And then something I choose to do is, now I wouldn't do this in a big data project, but since I have a smaller data set, I go ahead and I sort everything by the row average and the column average. This way I know that the rows at the top will have more missed questions. The rows at the bottom will have more correct questions. And then the questions at the far left will have been missed more, and the questions at the far right will be missed less. All right, so this way, as I look through, I have kind of an intuition on how things are going as I look through my data. This might help me spot any patterns as I investigate and work through. And this is something that I would do at work for this size of data set. All right, so let's go ahead and do block clustering. Now, when I'm doing binary block clustering in the block cluster package, I have the option of having a beta prior. Now, if I don't specify a prior, what it's going to do, it's going to go ahead and accept the uniform distribution as the prior. I went ahead, I picked 8 and 9 as the alpha and beta parameters, just because that looked about right for the overall global aspect. Now, so one thing to always be mindful of is if I have a good model structure, things tend to, first of all, they'll fit better. Like my model will fit better on my data. Second, things usually converge faster. So I feel like it's a good idea to go ahead and put a beta prior of 8, 9 on this data set, because that gives me approximately the overall average for, if I take all the questions, all the students, and just take the average of all the zeros and ones, it's about 8/17, roughly speaking. Now, you'll notice that I did not go with like a larger values for that. As picked like, single digit integer numbers. The reason why I did that is because if I go with larger numbers, then the variance of the beta prior will be much lower, and that corresponds to me being very, very confident in my prior. Here, I'm not that confident in it. So here, it's going to be like a flatter, more distributed data set or distribution. Now, the next thing that we need to think about is that when we are looking at our clusters, remember I have clusters on rows and columns. So what I'm going to end up doing, I'm going to have two rows for clustering. So students will be in 1 of 2 groups. Questions will be in 1 of 3 groups. Okay, so it's a total of 6 groups, and we can say that either we believe that we have a constant mean, and we can, or not, so equal means, unequal means among the groups, and we can say either equal dispersion or unequal dispersions within each of the clusters. The default is assume that you have unequal means and unequal dispersions both times. I recommend that you go with this, which is the default, by the way, unless you're on a small data problem. If you're on a small data problem, then you don't want to be evaluating very many parameters. But then again, you probably wouldn't be doing this. So unless you have a strong reason to, I would go ahead and just leave it on the default setting. I went ahead and included it in the model call, just so that you know that that option is there to get rid of it. All right, so in the block cluster package, it's the co-cluster binary data set or function. Here, data is the data I want to pass in. Now, the number of co-clustering that I want to put the rows into 2 clusters, and I want to put the columns into 3. 2 times 3 is 6. So really, I'm putting the composite of student and question into 1 of 6 clusters. All right, now here is the prior. So 7 is my, oh, whoops, I meant to have an 8 there. Well, we'll leave it. I have a typo. I meant to have 8, 7, 8. It's not that big. It's a 0.11 difference in the mean. I think it'll still work out. All right, so here's the alpha of my prior. Here's the beta of my prior. So remember, when we're talking about beta distribution, the larger the alpha, the more push of the distribution towards 1. And the larger the beta, the more push to the 0 side of the distribution. Here, we're getting a little bit more push towards the 0 side. So the mean will be less than 1/2. And this part, the strategy, this is how I control the parameters of the algorithm. These 2 parameters is controlling the number of steps iterated on this. The larger this number, the longer it's going to take to compute. But the flip side of that is that I can be more confident that it's converged to the correct value if I have more iterations, more steps allowed. And it gives us a notice if it does not successfully converge, successfully terminate. And so here, we're looking good. So now let's look at the results. I'm going to use a summary function with object set to the co-cluster object. And we have a Bernoulli, a 0-1 latent block model. And here, this specifies that we have unequal means and unequal dispersion within the clusters. And this is unsupervised clustering. There is a supervised clustering, which I would just do supervised modeling, supervised, predictive analytics, supervised, I would use a different model structure for it, but yeah, it's available. It's there for you. Check it out. It's pretty cool. All right, so here we have the class means of zeros and ones, kind of giving us an idea of where is this landing. Does it look like we have more zeros or more ones? This package, it treats a 0 as false, false as 0, 1 is true, true as 1, like back and forth. And so you just kind of have, when you look at this, you have to keep that in your mind, that if you see true, false, it's the same as 0 and 1, 0. All right, now here's the dispersion for each of these. So here we can see that we've got 0.3, 0.2, 0.1, 0.1, about 0.1, and then 0.3. And then here are the row proportions of 0.6 and 0.4. And then we have the column proportions of 0.3, about 0.4, and then 0.3. Okay. And here is the log likelihood estimate. And then it reminds us what our parameters are for our prior distribution. All right, so let's take a look. What this plot does, every time that it's a 0 in my data set, it puts a black dot. Every time it's a true, it puts a white dot or no dot. Actually, probably what it does. And I can look, here's the original data. So visually, when I look at this, I can see very clearly that there are 3 clusters for the columns. That is as clear as day. But now the number of clusters on rows, that looks a little bit tougher. I mean, it's not real obvious what's going on here. Now remember, I did sort these beforehand, right? I did sort these so that, yeah, so if I scroll back up, we'll take a look at that. Here, I sorted the rows by the row means. I sorted the columns by the column means. That way we have kind of a coherent initial look. So because of that, it does make it a lot easier to spot that we have 3 column groups very naturally. But when it comes to rows, it's not so clear. All right, so here's my original data after I sorted it, by the way. And here is the post clustering data. So what it does, it moves the rows into their row cluster, and it moves the columns into their column cluster. And so when I see this, if I have good clustering, I'll have very dark or very light groups. And so the darker the group, the more I can go, hey, that looks like a good clustering. The lighter the group, I can say, hey, that looks like a good clustering. If it's a gray, if it's in the middle, then it's like, is this an improvement? I don't know. So when I look here, I can see that this group of students in questions, that's pretty dark. This group of students in questions is very dark. Here, this group with the student in question combination is very light, and this combination of student in question is very light. So if we're in the situation where this is test data, the students that are in, after clustering, the students that are in the first cluster should get remedial work on the questions that are in this block here. So the columns that are in this cluster should be the remedial work for the students at the top of the data set. Now, the students at the bottom of the data set, I want questions from the third cluster. Now, after the students have mastered these concepts, the first group should move on to the third group of questions, and then the second group of students should move to the second group of questions. Actually, no, I take that back. I interpret this is incorrect. We know that the students as a whole, the first row students mastered this content very well, and so we don't need to touch it. And the second row students mastered this content very well, so we don't need to touch it. So these students, after mastering the first group of questions, would go on to the second group. These students down here, after they master the third group of questions, they would go to the the first. And so that gives me a game plan for what to do if I want to break up my students into groups and then give instruction based off of their groups. Now, one thing we can do, we can look and see another way, how good are our clusterings? So here, this is the overall zeros and ones in the data set. If I move up here, I can see that first row, I can take a look at how many missed and correct we have for as a whole for all students over all of those questions. And then this is for the second row cluster. And these different shaded blocks indicate which group of questions we're talking about. And down here, now I'm on the first cluster of questions, second cluster of questions, third cluster of questions, and we can look and see the difference. Like, so if I see a big difference in the bars, that's an indication that I have a better grouping. And so here, that's pretty good. And second best is maybe this one or that one. This is not that great of a grouping because they're so close, but we do see that there is kind of a difference in the rows. So there are, and then we can go bit by bit and we can look to see, like over here, there's going to be a lot of missed questions, good number of missed questions, not a good number, but, and then a good number of missed questions here. We can see here and here, this combination of students and questions, they've already mastered it. We don't need to dwell on it. This combination of student and questions, they've already mastered it. We don't need to dwell on it. Now you'll notice that it doesn't really do a good job of plotting some stuff on the title. I couldn't fix that. That's the output of the function. Now, how do we actually get the clusters out? Because after I've done this, I need to pull out like which, little Johnny right here, which group is little Johnny in, which group is little Janie in. Well, what I can do, I can go to my co-cluster object, and now here I use @rowClass. I use @rowClass, and that will tell me what what cluster each student is in. Now, what for the columns, for the questions, I take my object again, and I do @callClass, and that gives me which cluster each question is in. Now, you'll notice that they start at 0, just like with the C programming language. That's not how R does it. A good portion of Python does it this way. It's done this way because of Python. All right, well, that's all I've got for you. Take care and goodbye.